So, what do you understand by linear programming? Under this topic, we are going to talk about introduction to linear programming. Let me look for a space, okay? We are going to dissect introduction to linear programming. Then we talk about the underlying assumptions of linear programming model. Then you also need to learn about the uses. You should learn about uses or areas of application of linear programming. This one, you are the one that will do it by yourself. Okay? Then talk about limitation of linear programming model. Again, you will read that one by yourself. It's then in the material. Then we talk about methods. We are going to talk about methods of determining optimal production plan. Method of determining optimal production plan. Okay. Then we talk about shadow price. Shadow price. Then we are going to have illustrations. Okay, so these are the scope. These are the areas that we are going to touch as far as linear programming is concerned. If you know all of this, okay, that means you've already know linear programming. All right. If you have or if you know any of these items that I listed, that means you are good. You are good as far as linear programming is concerned. So I repeat once again, for the uses of linear programming, as well as the limitations of LP model, all right, you are going to form a note on that. It's in your study material. So it's in your study material. You can go through it. Okay. So let's take it one by one. You can open to the material at your end. All right. So what do you mean by linear programming? You will recall that when we had optimal product mix decision, I told you that, of course, there are two types of constraints. We have single constraint and then multiple constraints. Under multiple constraints, I mentioned to you that linear programming is used when there are more than one uh, constraints, okay? Because under that circumstance, you cannot use optimal mix for your allocation. Therefore, what is linear programming? Linear programming is the mathematical modeling of allocating limited scarce resources among competing product lines in a judicious and efficient manner to achieve organization's single economic objective. That is linear programming. It should be noted that linear programming is used when there are multiple constraints. That is, when there are more factors of production that are limited in supply. For example, raw material, kilogram, labor hours, and matching time may not be sufficient to maximize contribution towards profit. Therefore, the little resources available will then need to be allocated among competing product lines in a judicious manner in order for the company to take advantage of market condition. So that's basically the introduction to linear programming. One thing you need to understand is that as far as linear programming is concerned, it's a model designed principally to allocate limited scarce resources among competing product lines when there are more than one factor of production limited in supply, when there are more than one constraint, or when there are multiple constraints. All right. So that is as per introduction to linear programming. What I'm trying to say in essence here is that, when you want to produce, you are going to need material kilogram, right? The company will need material kilogram. The company will also need labor hour. Okay, you need the labor hours. Not only that, matching time. Matching time will also be needed. All right. So when two or all of these three resources are not sufficient, in that case, you are supposed to use linear programming to allocate or to determine optimal production plan that will enable the company to maximize a single economic objective. When you say single economic objective, it means that the company has only one objective to achieve, either to maximize contribution or to minimize cost. Okay, so when more than one factor of production are limited in supply, you need linear programming to allocate limited scarce resources. So that is as per the introduction to linear programming. The next item is the underlying assumptions of linear programming. Okay, so the assumptions of linear programming, there are about 5 or 6 of them. Okay, the first one, the first assumption of linear programming, let me put it down for you, then I will explain. The first assumption of linear programming is single economic objective. Single economic, okay, objective. All right, what do you mean by single economic objective? This assumes that there must be only one objective to be achieved. That is, either to maximize contribution or to minimize cost, but not the two at the same time. Even though in practice, company can uh, company may want to achieve several objectives at the same time. So the company that wants to maximize profits may also wants to minimize costs. Not only that, the objective of a company may be to satisfy customer demand, or to enhance customer experience and satisfaction. Okay? So another objective may be for employee satisfaction. All right? So different objectives can be achieved in practice by an organization. But as far as linear programming is concerned, because if all these assumptions are not in place, then it will be difficult to use linear programming for determining optimal production plan. So for the model to work effectively, all these assumptions must be in place. So what we are saying is that there must be a single economic objective to be achieved, either to maximize contribution or to minimize cost. Then number two is divisibility. All right, divisibility. Okay, you can call it divisibility or fractionality. This is premised on the fact that uh, um, fractional output can be produced, and that it is not compulsory that a company must produce the entire output set out to produce. For example, if you want to produce, you have intention of producing 100 units of a product, but because of limited scarce resources, you don't have sufficient raw material to produce. Therefore, out of that 100, you can produce 70%. You can produce 90 units. You can produce 33 1/3 percent of the units you set out to produce. So fractional output can be produced. That's the meaning of divisibility. All right. So you can divide, you can produce part of it. So that is what divisibility is talking about. Divisibility. That's not correct. Ability. Then number three, you talk about another assumption is certainty. Okay, certainty. What does this say? This states that, let me write it clearly. This states that the factor of production required for manufacturing the final product must be known in advance and with certainty. I repeat, This states that the factor of production, including raw material kilogram, machine hour, and labor hours required for production of the company's final products must be known in advance and with certainty. So what we are saying is that before you go into production process, you must know how many kilogram of material do you need, how many labor hours do you need to produce, how many machine time will be required. So you don't just get to the production before you begin to talk about, okay, I'm going to need this. You need to know it in advance and with certainty, the quantity that you are going to use for your production. That is what certainty is talking about. Then number 4, we talk about linearity. Linearity. Linearity measures relationship between two or more variables. All right. So this linearity assumption states that the relationship between the objective function and other factors of production must be expressed in linear fashion. Okay? The relationship between objective function and other factors of production must be expressed in linear fashion. So when you say linear fashion, okay, what we are trying to say is the fact that when you talk about linearity, rather, so let's say, for example, you have material, when you express something like this, let's say we have 5 kilogram of material A plus 4 kilogram of material B less than equal to, or simply say equal to 100 kilogram. So when you express something like this, it's what we know as linearity. That's linearity. This is what we mean by linearity. Anything you express in this fashion is what is called linearity. Okay, so what we're now saying is that the relationship between the objective function and other factor of production must be stated in linear fashion. Okay? Then number 5 is non-negativity constraints. Non-negativity constraints. This state that negative output, all right, negative output is not permitted and that the minimum that can be produced is 0, okay? Negative output is not permitted and that the minimum that can be produced is 0. That is what non-negativity constraint is talking about. You cannot produce negative output, all right? So that is as per that. In your normal graph, for example, in mathematics or in statistics, you have two sides of the graph, the positive side and the negative side. Say, for example, this is a graph, all right? This is a graph. This is y-axis, for example. This is x-axis, all right? This is the positive side. This is negative side. All right. But as far as linear programming is concerned, under mathematics or statistics, this is how your graph look like. As far as as far as the linear programming is concerned, linear programming is saying that there is no negative output, and that's what the non-negativity constraint is talking about. And that's why under linear programming, when you construct your graph, you don't have anything negative. Your graph will look like this. So you can say this is y axis, this is x axis, for example, and the minimum will be equal to 0, nothing like negative. So this is what we mean by non-negativity constraint. So these are the 5 underlying assumptions of linear programming. Okay, so examiner can ask you, because it is examinable. This assumption is examinable. You must understand what each of them is talking about. And you also need to, when the examiner is asking you to explain the underlying assumptions of linear programming, you have to give example of each of them for you to be able to earn your full mark. All right. So that is as per that. So like I said, you are going to read, all right, you are going to read the applications of linear programming yourself. Just form a note. is in your study material, all right? If you have the golden book, you see it there in details, okay? So let's move on to methods of determining optimal production plan. Basically, there are two methods of determining optimal production plan. There are two methods of determining optimal production plan. We have graphical method. We also have the simplex method. Simplex method is no more, it's not in your syllabus. All right. So for the graphical method, when you have only two variables, that's when you use graphical method. Say, for example, you can be given product A and then product B. These are two variables. So when you have only two variables, then that's when you use a graphical method. But when you have more than two variables, you cannot use graphical method. It has to be simplex method. All right. And then each of them has its own underlying way of determining optimal production plan. However, our focus is on the graphical method. How do you determine optimal production plan using the graphical method? Let me stop sharing this so that I can just show you. Okay. Um, linear, no, linear programming. Okay. So to determine the optimal production plan using linear programming, the following procedures should be considered. Let me just put it down. Procedures involved in determining optimal production plan. Optimal production plan using the graphical method. Okay, so how do you do this? Very straightforward. Linear programming is very interesting and easy to understand. The only issue with linear programming is that it takes time, especially if in the question you are asked to determine shadow price. All right. So if you have to determine optimal production plan, that's a long process on its own. Then the examiner is now asking you again to determine shadow price. If examiner wants to add to your burden, it will also give you additional requirements. And then before you know it, you just be there because you love linear programming. It's easy. You are just there. Before you know it, you are spending 1 hour plus. You are still on linear programming. All right. In fact, on the day of your exam, I will advise you don't even make it your first attempt because it will take your time. You won't know that time is already gone. So, and that's why it is important whenever you are given a question on the D-Day, all right? So just go through all those questions with the one that you can solve within 20 minutes or even less, maximum 30 minutes. So quickly you pocket like two or three of those, then you can now come and balance on the other ones, especially the compulsory, you know. Again, like I mentioned, linear programming is one of the most frequently tested topic in ICAN. So, right. So, of course, it came out last diet. It came out last diet. But again, yeah, let's move on. The first step that you are going to carry out, step one, whenever you want to determine optimal production plan. Step one is to uh, define the variables. All right, you define the variables. What do I mean by this? You know, on the day of your exam, in most cases, examiner will not call the product. The product will not be represented in letter. At times, examiner can say product good, product bad, or product big, product small, product excellent, product fine, product ugly. So the product will be represented in words, but you don't use words whenever you want to construct your graph or whenever you want to represent the in equation. You know, the other time I talked about linearity assumption. Okay, so when you want to express the relationship in linear fashion, so you cannot be using words for to do that. You need letter. Therefore, you need to define the variable. Say, for example, you are given a product. Examiner has called this product to be good, good, then mom. Okay, you are given a product to be good, then mom. So in this case, of course, you cannot say five of good, five of five of good plus two of mom. So you can't say that. So you need to express this. You need to define the variable by then saying let good equal to g, for example. Then let mom equal to m. So with this, you can say 5g, then 2m equal to 100. So it's easier that way. So this is what I mean by define the variables. So step one is to define the variables. Okay. Then step two is to formulate the linear programming model. Formulate the linear programming mathematical modeling. So how do you formulate? There are three steps that you are going to carry out anytime you want to formulate linear programming model. Step one is to state the objective function. Okay, state the objective function. How do you state the objective function? You go to the question, what's the objective that the company wants to achieve? Is it to maximize contribution or to minimize cost? Now, if in the question you can see information on selling price and variable cost, it means that you are going to determine contribution, which means the company wants to maximize contribution. At times, examiner may be straightforward. You can see contribution in the question, or you can see profit in the question. Once you can cite contribution or profit in the question, it means the objective that the company wants to achieve is to maximize contribution. But if you cannot see anything like selling price, you cannot see contribution or profit, it means that the company wants to minimize cost. So the clue will always be there in the question to tell you, to give you the direction, what the company or the objective that the company wants to achieve. All right. So in this case, let's say, for example, the company wants to maximize contribution. Under my objective function, I would then say maximization of contribution. I would then say equal to, let's say, for example, you have product A and B. So I would then say 5 naira of product A plus 4 naira of product B. With this, I have stated the objective function. This is how to state the objective function. The objective is to maximize contribution. So that's that. Then step two under this is to state all relevant constraints. I would then say states all relevant constraints. So I will go to the question. What are the constraints apparent in the question? Is it that raw material kilogram is not sufficient? Is it that labor hour is inadequate? Is it that matching hour is not enough? So the information will always be there in the question to tell you the limitation or the constraint or the bottleneck that are apparent in the question. So let's say, for example, material kilogram and labor hours are not sufficient. In this case, I would then say material to state the relevant constraint. I would then say material kilogram equal to, let's say we have 3 kg of material A, sorry, of a product A. So I would say 3 of A plus, let's say you have 6 of B. So I would say 6B. Because we are maximizing contribution, I would then say less than equal to, let's say you have 100 kilogram available. So with this, I've stated the constraint on material because material is limited to 100 kilogram, and I've done that. I've stated it, and then you can see this is expressed in linear fashion. This is what we mean by linearity, relationship between the factor of between the objective function and the factor of production must be expressed in linear fashion. Then let's say, for example, also we have labor hour. We are told that labor hour is limited to 120. Okay, I will say labor hours. Let's say we have 5 hours of product A plus uh, 2 hours of product B less than equal to maximum labor hours available is 120 hours. So with this, I have stated the relevant constraints. We have two constraints in this organization. Raw material kilogram is not sufficient. Labor hour is also inadequate. So I have stated it. This is how to state all relevant constraints. Then step 3 of the formulation of linear programming model is to state the non-negativity constraints. So state the non-negativity constraints, which states that negative output is not permitted. So in this case, I would just say, since we are using product A and B as our example, so I can say product A and B must be greater than or equal to 0. Or you can say A, B greater than equal to 0. All right. Or you can say A greater than 0, B greater. So this is how to state the non-negativity constraint, which is saying that negative output is not permitted. We can either produce 0 or more than 0, but not below 0. You cannot produce anything less because once you have negative, that means below 0, so which is not permitted. All right. So this is how to state the objective. How to state how to formulate linear programming model. If I want to put it in right perspective, I can bring everything together in a table. I can say objective function. For example, I will say objective. On the day of your exam, this is how you will do it. Objective function. Maximization of contribution equal. Let me go back to what I have there, which is 5A plus 4B. All right. 5A plus 4B. Okay. Then the next one is to state all relevant constraints. I would then say subject to, we have material kilogram is equal to 3A plus 6B. 3A plus 6B less than equal to 100 kilogram. Then labor hour equal to 5A plus 2B less than equal to 120 hours. Then I would then say non-negativity constraints equal to A and B greater than equal to 0. A and B must be greater than equal to 0. So this is how to formulate linear programming model. On the day of your exam, there is no need for you to say, state the objective function, state all relevant constraints, state the non-negativity constraint. You don't need all of that. All right. What you need to do is this is the exam method. This is how you are going to do it on the day of your exam. If you want to formulate a linear programming model, that's how you are going to state it. So there is no need for you to say state this, state that. So that's step 2 of determining optimal production plan. The next step, step 3, is to bring out the equation and solve using elimination method. Step 3, bring out the equations in step 2 and solve using elimination method. Okay, so all the equation that you have determined in step 2, it could be more than one equation. For example, material is one equation, labor is another equation. If you have other constraints, like for example, matching hour, so whatever the equation you have in the question, you bring them out. So in this case now, like in this our example, we have two equations, 3a plus 6b. So I would then say 3a plus 6b equal to 100 kilogram. This is equation 1. Then 5a plus 2b equal to 120 hours. First, you can remove the kilogram and the hours. So this is equation 2. I will then use elimination method to get value for A, elimination method to get value for B. This is what I mean by bring out the equation in step 2 and solve using elimination method. Okay, then step 4, you construct pivot table. Step 4, construct pivot table. So whatever the result of your step 3, all the figures, the value of A, the value of B in each of the equations, whatever you have done, you then put it in the pivot table. So that's that. Then step 5. Okay, step 5 is to construct a graph. Draw a graph. Okay. Then step 6. In your graph, you determine feasible region. Determine feasible region. In step 5 above. So from your graph, you determine feasible region. Feasible region, if you are maximizing contribution, feasible region is internal towards 0. Is the point of intersection towards 0. That would be the feasible region. But when you are minimizing cost, feasible region will be external. Okay, will be external outward 0. Okay, so that would be the feasible region. Of course, when you see live question, I will demonstrate that for you. But for now, this is what you need to do. Then step 7. Step 7, okay, you determine solution table or you construct solution table. Construct solution table. So in this solution table is where you are going to have your optimal production plan. Okay, that's where you are going to have your, like just like you normally have your allocation table. All right, this solution table is just like your allocation table. All right, your last column in the allocation table will tell you your OPM. So the same thing here. So if you are maximum in this your solution table, if you want to maximize contribution, you are going to select the highest contribution margin. If you want to minimize cost, it selects the lowest cost. Okay, so again, when you see live question, I will explain more in details. Then step 8, which is the final step. All right, you determine the optimal production plan. Determine the optimal production plan. So these are the 8 procedures that you need to carry out anytime you want to determine optimal production plan using linear programming. All right, using linear programming. So these are the procedures. Okay. Then finally, that we are going to discuss, the last concept that we are going to touch is shadow price, the concept of shadow price. Okay, concept of shadow price. All right, shadow price. So what do you mean by shadow price? The shadow price represents the extra contribution derivable from the additional units of limited scarce resources that have been fully utilized at the optimal level of activity. Okay, let me put it down for you. This represents the extra contribution, additional contribution derivable from the additional units. Let me write that. From the additional units of limited scarce resources that will be fully utilized at the optimal level of activity. Okay, so that's that. You know, in this step 7, where you have the solution table, that's where you are going to determine the optimal production plan that you are going to produce. So at that point in time, at that level where you have made your decision, that's the optimal level of activity, which represents the binding constraint. So, of course, what are the method of determining shadow price? We have dual method. Okay. Then 2, we have increase the number of constraint. Increase the number of constraint by 1. So in our next, this is where we are going to call it a day. In our next class, by the grace of God, I will explain to you in details what you are going to do under each of them. Let's call it a day from here. So we continue next time by the grace of God. Let me know if you have any question for me, please. All right. Any question? Okay. So in the absence,
What is that? Hello, sir.
yes, go ahead.
Help read what you wrote last. Increase the number of
Constraint by 1. Increase the number of constraints by 1. All right. So we will continue from here next time by the grace of God. Thank you everyone for waiting behind. I will see you next time by the grace of God. Good night.
Good night, sir.
Good
Yeah. Thank you.
night, sir. Thank you, sir.
You're welcome. Good
sir.
night.
Thank you.
Yeah. Thank you.
No, just sleep.